So, what's it going to be? Is it that donut you had for breakfast, or is it your family's genes that are really in charge of your health? Today, we're going to break down this incredibly complex dance between your DNA and your daily choices. And the answer, well, it's a lot more interesting than you might think. You've heard it a million times, right? Nature versus nurture. It's been this epic scientific tug of war for, ever. But here's the thing. Modern science has pretty much called a truce. It turns out picking a side is the wrong way to look at it entirely. The real key to our health is understanding how these two things work together. All right, so here's our game plan for this explainer. First, we're going to move way beyond that old-school debate. Then, we'll see how a whole bunch of genes can team up to influence just one trait, and explore what it means to cross this critical liability line. After that, we'll look at some powerful examples of how genes in your environment can dance together. And finally, we'll wrap it all up with what this actually means for you.
Okay, first things first. Let's stop thinking about diseases as just on or off. It's really more of a spectrum. On one far end, you've got conditions that are pretty much purely genetic. On the other end, things caused almost entirely by the environment. But most of the common diseases we worry about, they live somewhere in that messy middle ground.
You know, a single gene disorder like cystic fibrosis, that's like one major typo in a book that messes up the whole story. It's a clear cause and effect. But something like heart disease, that's way more complicated. It's not one single typo. It's more like a theme woven through the entire book, influenced by tons of different sentences, paragraphs, and chapters all working together.
And this brings us to a really important term, multifactorial trait. It sounds super technical, but all it really means is that a trait or a disease is caused by a combination of multiple genes and multiple environmental factors. It's a recipe with ingredients from both your DNA and your life.
So how does this actually work? I mean, how can dozens or even hundreds of genes all have a say in a single thing, like your blood pressure? Let's build it up step by step to see how this chain reaction happens. Okay, imagine a super simple world where just one single gene determines how tall you are. In that world, you'd basically only have 3 heights: short, medium, and tall. That's it. No in-betweens. It'd be kind of weird, right? Now, let's just add one more gene to the mix. Just one. And suddenly, you get more variety, more possible heights appear, and those big gaps start to fill in. We're getting a little closer to what we actually see in the real world. And this is where it all clicks into place. Because in reality, for traits like height, we're talking about hundreds of genes, each contributing just a tiny little bit. When you add all those tiny genetic effects together, plus environmental factors like nutrition, you get this beautiful, smooth, continuous bell-shaped curve. That's the amazing variation we see all around us every day. All right, this leads us to a fascinating puzzle. If the risk for a disease is on that smooth curve, why are so many of the diseases themselves all or nothing? You either have the condition or you don't. How do you get from a spectrum of risk to a simple yes or no? Exactly. I mean, think about it. You never hear someone say they have a little bit of a cleft palate. The condition is either there or it isn't. So what's going on? How does a continuous risk profile translate into such a discrete black and white diagnosis? The answer is a really powerful concept called the threshold model. Think of it like a tipping point. We all inherit a certain number of genetic risk factors, and we accumulate environmental ones throughout our lives. But the disease only actually shows up when the total number of risk factors crosses a specific line, a threshold. This visual shows it perfectly. Everyone in the population is on this bell curve of liability. Most of us are somewhere in the middle with an average amount of risk, but only the people whose total risk factors, genes and environment combined, push them past that vertical line, they're the ones who are affected. Everyone below that line remains healthy. So let's look at a real-world example, a condition called pyloric stenosis. It's way more common in boys than in girls. And the threshold model tells us why. Boys simply have a lower threshold. They need fewer risk factors to get tipped over the edge into disease. But here's the really crucial insight. Because the threshold for girls is so high, if a girl does get it, it tells us that her family must be carrying a very significant genetic load. It took a whole lot of risk to push her past that high bar. So far, we've talked about genes and environment kind of adding up, but it can get even more complicated. Sometimes they don't just add, they multiply. They interact in ways that create a dramatically different outcome. Let's check out this nature-nurture tango. This is a famous study, and it's absolutely mind-blowing.
Historically, colon cancer was pretty rare in Japan. But when researchers looked at Japanese migrants who moved to the US and adopted a Western diet and lifestyle, their risk shot up. By the second generation, born and raised in the US, their colon cancer rates were about the same as the general US population. Same genetic background, totally different environment, and a completely different health outcome.
And this right here, this is a devastating example of a true gene-environment interaction. There's a genetic condition called AAT deficiency. If you have it, but you're a non-smoker, your median survival age is around 62. But if you have that exact same genetic condition and you smoke, your median survival plummets to just 40 years old. It's not just an added risk. The smoking dramatically multiplies the genetic risk. It's a truly deadly combination.
Okay, so after wading through all this complexity, what's the bottom line? How do we actually apply this knowledge to our own health?
So here are the key principles to remember. Your risk is higher if more than one family member is affected. That makes sense. It's also higher if a relative had a particularly severe case. And remember that threshold idea? Your risk is higher if a relative of the less commonly affected sex has the condition. But the most powerful principle, the one you have control over, is the last one. You can significantly alter your risk with your lifestyle. And this is really the most important thing to take away from all of this. Your family history is not your destiny. It's not a done deal. Think of it as a roadmap. It highlights the potential hazards, the places where you might need to be more careful. It gives you the information you need to make smart, targeted choices to keep yourself on the healthy side of that threshold.
I love this saying because it just perfectly captures the whole idea. Our genes might set the stage, maybe they even load the gun. But so often, it's our lifestyle and our environment that actually pulled the trigger. It's a powerful idea to keep in mind. Thanks for watching.